Hello everyone. So we have already seen DREF spinning technology 1 and 2. So today we are going to discuss method 3. So what is the principle? Operating principle is based on the feeding of two different independent fibers. So how does it work and what is this construction working? We'll go to see. So let's see first about the construction, then we come on to the working. Okay. So the construction is based on three methods. So what type is, see, let's go from the figure. So from the figure, this is called drafting unit 1, right? So this is drafting system 2. So think that, see, the drafting system unit 1 is positioned before the central part of the spinning system. See, this is the whole spinning system, right? So here, before that, we are placed with the drafting unit 1. Okay. Then, so drafting system 2 is where it is positioned above the nip of the spinning unit. Yeah, this is the spinning unit. And from here, we can see above, there is a drafting system 2. Okay. So the spinning unit will then compose these fibers to the sheet fibers around the core fibers, then wound on the cheese pull. So to understand spinning unit, we'll go for the working of it. So one thing it is definitely known, there were drafting unit 1, drafting unit 2, and where they are positioned. So according to the spinning unit, let's see the working. See, working. What in the drafting unit 1, we are going to place second passage draw frame sliver is fed. Okay. See, there, like, see here drafting rollers were there, right? Here we are feeding, what we are feeding, second phase draw frame sliver. So what is mean by second phase draw frame sliver? That means the draw frame fiber is taken, then it is redrawn, then the fiber is taken to feed here, and that fiber, after, see, after this, whatever the fiber was there, that was fed in here the drafting rollers of the drafting unit 1. Then that whatever the out, the which were the drawn from the rollers are called core fibers. Okay, are called core fibers. So from there the fibers will come. Then from the drafting unit 2 will get what will get. So see, the second phase draw frame sliver is fed to the drafting system 1, and they are drawn to form core fibers. So the fibers which are coming from the drafting unit 1 are called core fibers. Okay. So from delivery rollers of the first drafting unit and to the take up rollers to of take up rollers. So from here, let's see. From here, delivery rollers to the outlet, what happens is it um, a false twist is imparted to the core fibers. So this is like, it is a problem. Like, to avoid this effect, it is necessary to feed the second fiber. So avoid this fault twist in core fibers, we are introducing second fiber for covering. Okay, for covering of the core fibers. Okay. So what are those core second fibers which can cover the core fibers? Those fibers are called sheet fibers. So sheet fibers are used to cover the core fibers in the spinning unit, which results in the permanent strength. See, for example, there are two, for example, there were two was there. So then it will become more strong, no? So the fiber will become permanent strand. The yarn formed therefore is called bicomponent. So we are giving two fibers, so then it comes bicomponent also. So from where the second fibers will come out? So the drafting system 2 was there, right? Above the nip of the spinning unit. Then from there, from their funnel, we'll get this second fiber, that is called sheath fibers. So what in this in spinning unit, we'll get this composition of these fibers, then will wound on to the cheese or poles. So this is of the construction, how does the material passage will come, and the construction working we have seen. So what does the definition? See, this is a core sheet type spinning arrangement. The sheet fibers are attached to core fibers because by the false twist is generated. Why this false twist is generated? Because the core fibers are uh, delivering from the delivery rollers by the rotating action of the drums. So here the false twist is produced. To avoid that, we are using another sheet of fibers that is called sheet fibers to the system. Okay. Two drafting units are used in the system, one for core fibers and for the sheet fibers. We have already seen one drafting one, drafting two, right? This system produces a variety of core sheet type structures and multi-component yarns. Very important. See, we have already told that bicomponent. So here, if we change different types, if, for example, if you are feeding different type of yarn material, then you will get different type of yarn properties, right? So that will be very important in this system. Through selective combination and placements of different material in core and sheet, we'll get different type of multi-yarns or any components. Okay. So delivery rate is also 300 meter per minute. So what do you think? So we'll get high production from here. So we have already seen construction. Now what is the yarn characteristics, which is very important, right? So what are the yarn construction? The system is intended to for long stable fibers, okay, producing specially carpet yarns from wool and synthetic fibers. Yes, the yarns are also similar to conventional woolen yarns with respect to, but the following is there: the yarn structure, bulkiness, surface appearance, mechanical properties, and one thing, these are very important for high elasticity and good regularity. So we can obtain more about this. And also, what is the special thing to mention about the drift spinning method 3 is we'll get multi-component yarns, and also the speed of the drafting rollers is 10 to 15 times the ring spinning. So you can even now understand how advanced it is. 10 to 15 times the ring spinning. And also, as this is very faster in work, it will avoid stick slip effects. What is called stick slip effects? Why? Because in the very slow running machines, we can see sticking, slipping type of effects, but here we can avoid that. A constant level of fiber to fiber friction is applied. So I already told that drift spinning is also called friction spinning, right? So a constant level of fiber to fiber friction is applied here. Yes. So I also wanted to tell you that um, the whatever the drafting system was there in the spinning unit, we will have a um, very good perforated cylinders. Very good perforated cylinders. We can see that. So this is spinning unit, whatever the spinning unit is consisting. So the spinning unit is composed of two perforated spinning drums with their own suction devices. So according to that, we have already seen the composition will come from the spinning unit only, right? So there will be only suction system where is their own, and that will be given wound to the cheese or pool later on, right? And one thing is very important, they are responsible for the permanent strength, and also will get bicomponent fibers, multi-component fibers. Okay. So this is all about drift spinning methods. Thank you so much for watching.